The second model we are supposed to discuss with respect to your liquid dielectric as well as the solid dielectric. So let us see here what all the things we'll cover here. So most of the things are very short notes, and theory part is uh, present in this second part of the first model here. So first topic here, that is classification of liquid dielectric. So here we are supposed to, the second part, the conduction and breakdown in liquid as well as a solid dielectric. So under that, the first topic is classification of liquid dielectric. What are the liquid dielectric we have? So in general, which dielectric we make use in a power system? So we'll see one by one here. So here in the recent years, we make use of some mineral oils which could be polyester oil, which have been developed extensively used in transformers, like in Europe countries and other countries. So there is one such oil which is very very famous, so which has been used for almost many years. So that is given as PETFP oil. So it stands for, it's actually a halogen free oil, wish to say. It's actually a halogen free oil. So this name is penta ethernite terrafatty acid polyester oil. Penta ethernite teraphatic acid polyester oil. So this was a very famous oil which has been used in Europe countries as well as other countries because of it has very good electric property first of all, and physical and thermal property, and also it is also biodegradable. So when it is decomposed, it has almost negligible toxicity present from that oil when you are going to decompose that, and it's not going to pollute that much. The pollution created by the decomposition of this oil was very very less. Because of that reason, they have been used this oil in Europe as well as other country. So let us see the classification here. There are basically 6 classification. First is a transformer oil, or we also say mineral oil, and synthetic hydrocarbons, chlorinide hydrocarbons, silicone oils, and ester and latest developments in this liquid dielectric. So we'll take one by one. The first one. So here, so transformer oil is a most commonly used liquid dielectric in power operators. Wherever we go that, we make use of a transformer oil as a insulator, dielectric insulator as a liquid dielectric. So why? Because in almost it's a colorless liquid. It doesn't have any color. It consists of a mixture of hydrocarbons, which includes paraffins and naphthenols and other minerals, which are very important in terms of electrical property, because it gives it can withstand very high temperature. It is not easily inflammable, right? And it is not so corrosive because there are few reasons because of the corrosion happen, but this transformer never create any corrosion. So because of that advantages, they make use of a transformer oil. And this transformer oil, when you make use in any application, whether it's a transformer application or if you are using for a capacitor or anywhere else as a insulator in a live connection, so we can say in other words, when it is in service, when you have connected transformer for the power source. So in that case, the liquid in this transformer is subjected to be prolonged by heating of high temperature up to 95 degrees Celsius. It can withstand, it can withstand up to almost 95 degree heat can be prolonged here. So this is the first case. And also it undergoes aging process also. So year after year, if you continuously, if you make use of this transformer within a time period, the oil become darker due to formation of acids and resins or sludges in the liquid. So because of this, the transformer oil will change its color. Okay, initially it will be in the no color, colorless. Later it convert to dark color because of the acid formation, resin, or any sludges within the liquid. So we have to remove these acids and these sludges. Why? Because if you're not going to remove this, this will create a corrosion. So these acids are a corrosive to the solid insulating material. So whichever we have a solid part, so there will be corrosion within the solid insulating material. Like it could be metal part of the transformer, or it could be your windings, core of the transformer, or coil within the oil duct, right? And these sludges will be going to deposit on the oil duct, so that there will be no circulation of oil is going to happen. So hence what happened, the temperature will rise, the transformer temperature will rise. For that reason, we need to take care of this. Whenever the color changes, we need to replace that transformer oil. So that's the reason we have a breather in a transformer. Hope you might have heard this. So when you visit any power station, you can see whenever there is a power transformer, next to the power transformer there will be called as a breather. So where the breather will be visible, it's a transparent glass which will be filled with a silicon gels. So which will be in a blue color. So whenever the transformer oil has to replace, or any moisture content is present within the oil, so that indicates a breather color, this breather silicon gel color will change. So then that will indicate that we have to replace the oil. So whenever you have a chance to visit any power station, you can have a look of that breather over there. So next one is synthetic hydrocarbon. So among synthetic liquid dielectric, so where polyphene are the dielectric of a choice for application of a power cable. So the polyphene is a dielectric which make use for a power cable. So over 55% of hydrocarbon produced worldwide today are polyphenes. So the most commonly used polyphene are hydrocarbons. So we are categorized as a mineral oil. It is similar to the mineral oil that is anything but a transformer oil. And the third one is chlorinated hydrocarbon. So these are basically two aromatic hydrocarbons. So which we have a chlorinide to produce these aromatic compounds, like it could be polychlorinide, or it is also called as a PCB, which is nothing but polychlorinide bipenal. So this is a way they make use of a chlorinated hydrocarbon. So actually this poses very high fire point. It will never catch fire easily. It has very high fire point and is excellent electrical property. So because of many reasons, so because this is very dangerous mineral, we can say, so that's the reason throughout the world it has been banned. So nowadays we are not using this mineral throughout the world because it has been banned for it, because of the serious problem, health problem also, because of this mineral. So to replacement of this chlorinated hydrocarbon, we have a substitute is silicone oil. So this is an alternate, as I mentioned, so which are very expensive, but this is a replacement for chlorinated hydrocarbon, which are very expensive. So it can withstand a temperature of almost all 150 degrees Celsius. It can withstand a temperature till 150 degree Celsius. And in the long term, it has very good thermal stability also. And most of the chemical that are oxidation or any other high temperature, so these high temperature than the mineral compared to the mineral oil, very high temperature. And silicone oils are acceptable substitute for, as I mentioned, PCB. This is substitute for PCB in a transformer, despite of having a inferior non-flammable property. So even though there are few drawbacks, because of few advantages, they choose over the previous chlorinated hydrocarbon here. The next one is ester. So ester are basically, there are two types where the natural ester, nothing but a castrol oil, which has been used in a capacitors. So in the capacitor, we make use of for a impregnant paper type. So that is something but insulation type, impregnant paper. Right? Instead of paper, we make use of this oil as a ester as a impregnant in the capacitor. So the two types of synthetic ester are organic ester and phosphate ester. So there are two types, organic and phosphate ester. So this organic ester, which is having very high boiling point, and which the viscosity is also very high, and they have very high fire point also, organic ester. So they are very good viscosity, and the temperature relation are used extensively in the capacitor. Whereas the other one, phosphate ester, which has high boiling point once again with a low flammability, and therefore it is used in the transformers. So because of the low flammability, they are used in a transformer, and they are used in wherever necessary, some area where the fire can catch easily. In that cases, they make use of this kind of ester oil. And the last one is the latest development. There are two latest development. First one is, we say as a HTH, that is nothing but high temperature hydrocarbon oil, and the other one is C2Cl4, that is nothing but tetrachlorinide ethanol. So these are the two recent mineral oil which are developed in many countries. So because of they have a very good property, like very good electrical insulation property, and which can withstand very high temperature, where the temperature could be almost all more than 150 degrees Celsius also, and which has very high fire point also, and which reduces the heat transfer capability, and the viscosity is also very high. That is the high temperature hydrocarbon. The other one, where it is once again, it is a mixture of few mineral oils actually, so which has very low viscosity and which gives excellent heat transfer property. So because of this reason, they make use of this kind of transformer mineral oils substitution for any other liquid dielectric medium. So these are few classification of a liquid dielectric. So next we will see the characteristics of this liquid dielectric. What are the characteristics here? So basically there are three characteristics, that is electrical property, heat transfer characteristics, and chemical stability. So we'll first cover the electrical property, then I will come back to the heat transfer and chemical stability. So here, the electric property, which is essentially to determine the dielectric performance of a liquid dielectric. So we are supposed to determine what is the dielectric strength of that liquid dielectric medium. It could be anything. Just now we have seen the classification. Among that, any material if you take, so I need to determine what is the dielectric strength and how it is going to perform there. So this performance of the liquid of dielectric are based on its capacitance per unit volume or its permittivity, relative permittivity. Based on this, they will determine first one, and based on its resistivity also. And the third one, loss tangent, that is tan delta, which you already seen in the module 5. So that is a loss angle, which to say. So where tan delta or power factor also, which is an indication of the power loss under AC voltage application. If the power factor is very less, then we say that the loss is more over there. And its ability to withstand high electric stress, whether it can withstand the high electric stress. Based on this, the electric properties will determine the strength of that dielectric medium, dielectric liquid, any liquid, okay. So the second one here it is, so these are the table, just I will zoom here. So this is a table which gives us some dielectric property of a liquid dielectric. So where a transformer oil, cable, capacitor oil, cable oil, and that another oil which has been shown, which has been used in Europe and other countries. and silicone oil. So where if you observe among this oil, the silicone oil is having very high breakdown strength for a given standard gap of 2.5 mm. The gap is 2.5 mm and the temperature is 20 degrees Celsius. With that case, when we apply the voltage, the breakdown was occurring up to 15 kV for transformer oil and cable 30, and similarly we have a silicone oil up to 30 to 40 kV per mm. So if you keep a gap of 2.5 mm between the electrode and you apply the voltage, and these electrodes are immersed in this transformer within this liquid dielectric. Okay, any of this, it could be transformer oil, cable oil, capacitor oil, or silicone oil. So we immerse these electrodes within the oils and we apply the voltage, and between this electrode the gap is 2.5 mm and the temperature maintained is 20 degrees Celsius. For that, this is a breakdown strength of a oil. And similarly, the relative permittivity is given, and resistivity, specific gravity, viscosity, and reflection index, and few other parameters related to the dielectric property. Also, so maximum permissible water content within these oils. So we cannot have more water content. We have to heat the oil. We have to remove this oil content. We cannot leave the water over there. Okay. So hence it should be dry oil. We can say the oil should be dry. Dry means to say free from moisture content. Okay. So next we have the permittivity, the dielectric which have been the property which are seen in the table. We discuss one by one here. The permittivity. So most of the petroleum oil will vary from 2 to 2.6. The permittivity will be 2 to 2.6, and whereas a silicone oil will be having 2 to 73. So as which is shown in the previous table, we can refer that. And in case of if it is a non-polar liquid, then the permittivity is independent of frequency. But in the case of polar liquid, such as water, it changes its frequency. For example, the permittivity of water is 78 at 50 Hz and reduces to 5 to 1 megahertz. It reduces its property to 5 to 1 megahertz. So next one is resistivities of the insulation liquid which are used for high voltage application. It should be more than 10 to the power of 6 ohms, 10 to the power of 6 ohm meter, and most of the liquid dielectric are in the pure state which exhibits this property. So this should be pure liquid. It should not be any mixture of any liquid or any contaminant within the liquid dielectric. So then only it exhibits its property purely. So next is power factor. So power factor of a liquid dielectric under AC voltage will determine the performance under load condition. Already we have seen that the power factor in electrical property, it says that, so this will say what amount of losses is going to happen within a AC system. So basically the power factor is measured of the power loss, and it is important parameter in the cable and capacitor system. Whenever I am testing any cable, I mean I am using to transmit power using a long under UG cable, and capacitors we make use in a power system for a compensation capacitor bank. In that cases, this will be very, very important here. So however, in the case of a transformer, the dielectric losses in the oil is negligible. Why it is negligible? Because there are few other losses in a transformer like iron loss and core loss. Compared to that, this dielectric loss will be very, very small, hence it will be negligible here. The next one is dielectric strength. So the most important parameter is that is dielectric strength. If you take any parameter, any insulation medium, we first determine what is this dielectric strength, at what voltage it can withstand its insulation property. So later on it may break down, right? So that is an important property here. So the dielectric strength depends upon your atomic and molecular property of a liquid itself. It depends upon the atomic and molecular property of the liquid. Under practical condition, this dielectric strength depends on the material of dielectric, temperature, type of applied voltage, gas content in the liquid, etc. So these are the few parameters which will decide under practical condition. The strength will be decided based on this parameter. Which type of electrode I am using, whether I am using a point to point or plane to plane electrode, whether it is a uniform distribution or ununiform, non-uniform distribution, whether what is the temperature there, whether I am using a standard temperature or room temperature, okay, or any variable temperature I am using, and type of voltage, whether I am using AC voltage or DC voltage. If I am using DC voltage, whether it is a positive polarity or a negative polarity, and what gas content I am using within the liquid, whether it is a air, natural air, or any SF6 gas, anything else I am making use of that. Based on all these parameters, the dielectric strength will be decided in a practical condition.